Okay, hi. So today we'll be doing numerical solutions for algebraic equations. So equations that are such as f of x is equal to 0, right? Such equations, for example, where f of x can be a polynomial equation or a transitional equation. So while polynomial equations are equations that are x, like for example, x plus 1 is equal to 0. Such equations are called polynomial equations, and equations where the format is a, for example, ax plus x is equal to 0, like where a over here can be anything such as tan, cos, sine, etc. So such equations are called transcendental equations. So now we have four methods to solve such equations, that are the bisectional method, the regular false method, Newton-Raphson method, and irritative method. Today I'll tell you about the bisectional method. So bisectional method, like I told you, will be solving where f of x is equal to 0, right? So now, if there's always said that there are roots for such equations such as these, right? And these roots always lie in an interval, which can be, for example, a or b. Let's say this is the interval where the roots of this equation lie, right? So there are different possibilities available here, where let's say f of a, f of b is equal to 0, right? So the different possibilities. First possibility can be that if f of a is less than 0 and f of b is less than 0. The second one is where f of a is greater than 0 and f of b is greater than 0. Here it becomes negative because it's less than 0, and here it's positive because it's more than 0, right? So let's say whenever we have a center, it's A and B, they're 2 points of a range, so we call it C. So we take a center which is A plus B by 2, right? So now over here we can say that the root lies between A and B, right? But now if we compare f of c, right? So if f of c is less than 0, then we replace a, that is the a of the range, with c, right? So we can write this as c and b over here. So now c and b is where the roots of this equation lie. Whereas if f of c is greater than 0, that is it's positive, then we replace b with c here. So it becomes a and c are the interval where the roots lie. Let us look into an example for this. So let's say the question is to solve this equation: x cubed minus 9x plus 1 is equal to 0. So for example, let's say this is the equation, right? So what we're going to do is we're going to find different values of x, right? So if f of x is equal to 0, let's put f of 0. F of 0 will be, if you put 0 here, it's going to be 1. And then we put f of 1, f of 2, f of 3, etc. Okay. So now sometimes in the question they'll give you what interval they want you to take it out in. So let's say they'll give you the interval 0 and 1, or the interval 2 and 3, right? So here let's find out, because this is minus 7, minus 9 and 1. So now here you can see 1 is positive, minus 7 is negative, minus 9 is negative, 1 is positive. So here let's take an example of this interval 2 to 3, right? So here whenever we, after finding these out, you will mention the intervals here. So for this area, we have the interval 0 to 1, and for this area we have interval 2 to 3. Right? So let's try finding this interval. Okay. So now what you're going to do is we have to make a table. Just a second. Let me erase all this. Okay, so now we'll make a table here. So let the first be the iteration number. Iteration number always starts from 0. Then we have A, which will be the negative, right? And then we have B, which will be the positive. Then we have x of n, which is nothing but your C. This can also be written as C, right? And then we have f of C, we can write, right? So, yeah. So now we have our first, we'll start with the zeroth. So over here, what we are starting with, we're starting with the interval 2 and 3, right? And their values, corresponding values were minus 9 and 1. Now we have the positive. The positive here is the uh, second one, sorry, the negative here is the second one, and the third one is the positive one. Now if you find so now we'll find C. C is nothing but 2 plus 3 divided by 2, that becomes 5 by 2, which is nothing but 2.5. And then we have f of C. F of C we'll put into the equation. Our equation was x cube minus 9x plus 1 is equal to 0. So if we put it here, it becomes minus 5.8, right? And then we go to the first one. Now you see over here f, like I told in the previous slide, here f of c is minus. It's minus, hence we'll be replacing the a value, right? Over here. This is a negative sign. So whenever we have a negative sign in f of c, we replace this, and when we have a positive sign, we replace this. Negative, so this will become c. So we replace c over here. This becomes 2.5. Over here, really you don't really need this value, you just need to know whether it's positive or negative. This value isn't used anywhere. So even if you're not calculating the whole value, that's totally fine. You can always just know whether it's going to come negative or positive and then continue the whole process. And then we'll leave B as it is. So then C will become 2.5 plus 3 is equal to, will become 2.75, and your f of C becomes minus 2.9. It's minus again, so again the C value will be changed here. So 2, it becomes 2.75, becomes 3 again, 2.88 minus 1.03. I'm just going a little fast because I don't want to calculate all of this right now. Okay, and then we go to third value. I want to show what happens when the positive value starts entering. So we'll go really quick. So this will become 2.88 since it was negative here, and then this is 3. It's 2.94 minus 1.05, right? Similarly, we go for the fourth one. We replace the A to 2.94. This is 3, 2.97 if I'm not wrong, and this becomes 0.47. So here you can see this becomes positive. So now in the fifth row, what we're going to do is we're going to keep A as it is, similar to this. So 2.94. Whereas we'll change the B value with the C value, right? So it becomes 2.97. Okay, so this is how it basically works. So now so how long do we keep going like this, right? So usually in the question they will give you to find it up to two decimal points or up to 3 decimal points, etc. So if they're telling you to find up to 2 decimal points, make sure you find up to 3 decimal points. So for example, if I keep going this, uh, the place where we gain our first 3 decimal points will become the eighth, right? Which is 2.94. Here again, it will be 2.9438, 2.919, and this will become 0.17. Okay, 0.017. I'm sorry, 0.017, right? So over here you can see that this is a place where we get a 3 decimal points, right? So now after getting the 3 decimal points, for example, if they have asked for 2 decimal points, you always find up to 3 decimal points and then you round it off, because if there's, and for example there's 3.1456, for example this is your answer, then to keep it to two decimal points, you check the third. If it's more than 5, that if it was 8, this would become 3.15. If it was 3, it would become 3.14, right? So this is how you usually convert when it's in decimals, right? So whenever you find your third value, so the value of the is converted after two decimal points. So this is one example. In the next video, we'll look into one more problem for the same method. Thank you.